Thank you. Yes, so what I'm going to talk about here today is how to build a robust what you see is what you mean editor in the browser. So by what you see is what you mean, we usually mean something like what you see is what you get, whereas you have a visual representation of your content and can just edit that in the obvious classical way with a cursor and a selection. But instead of editing things like fonts, font sizes, margins, stuff like that, you're editing semantic information. So you get a reduced, cleaner representation of the document where you say, this is a paragraph, and this is a link, and not this is Georgia 15 pixels italic. This is usually beneficial when you want to have users edit content and you then later want to use it in a different layout, in a different context, or you want to inspect it and transform it somehow. It's very useful to have semantic information about the content rather than just layout information. So my newest project is called ProseMirror. I'm going to be talking about CodeMirror and ProseMirror now and then. You shouldn't confuse them. CodeMirror is a code editor. ProseMirror is a semantic rich text editor. So something like a WYSIWYG, but for clean content. This was recently launched and open sourced, and it's my attempt to build an editor where you can define a schema for your content and have the editor automatically enforce that and provide the user with editing actions that stay within your schema. So if you have, for example, your GitHub and you have a document model that includes references to issues and to commits, you can extend your document model to have like first-class notes for links to commits or links to users, whatever, and have your users actually be working with a data model that corresponds to what you actually want to work with. ProseMirror also supports collaborative editing, and it's generally, I hope, the future of in-browser prose writing. So yeah, I'm going to be talking about how it's implemented, and a major factor in any kind of rich text editing implementation is the browser API called contentEditable. This is what enables many browser, almost all in-browser WYSIWYGs to even exist at all. And yet, if you talk about this to people who've actually worked with it, you'll get complaints and lots of horrible stories. So let me give a bit of background history. So the year is 1979. Microsoft is on a roll when it comes to browsers. They've just ported JavaScript, introduced dynamic DOM manipulation, and then I guess, I don't really know what happened, but I assume someone there said, let's make our browser an editor so that people can write HTML in the browser. And this is a very commendable idea, definitely. So what they ended up doing in IE4 is introducing a feature called design mode. That's a property you set on your document, which makes the whole document editable. Meaning, well, what it means exactly is still not clear. There's no spec which covers this, but basically you get a cursor and a selection, and you can type into it, you can backspace out stuff. And a companion to this API is a document.exec command, which your scripts can call, pass it a string like bold or italic or insert ordered list or delete to perform other editing actions on the document. So what you could do since IE4 is create a frame, set it to be editable, and then bind some key bindings and buttons to various exec command calls, and you'd have a basic WYSIWYG editor. This has worked since 1997, and then in 2000 they added a second feature very similar to that called contentEditable. This is the same as design mode, but per DOM node instead of for the whole document, meaning you don't have to create an iframe. You can just, for example, in your existing content, set a switch to make it editable, to let your users add something to a piece of your page and then save it somehow. Other important thing that you could do since this feature was introduced is set pieces of an editable DOM node to be non-editable. So you could set it back to false to the inside of some node. And that means that, well, the users can edit the text around it, but they can't move their cursor into that node and start editing there. And this is also a big improvement. It allows you to protect some parts of your document or insert widgets that aren't necessarily editable. So this was pretty much before the big JavaScript boom, but people were slowly starting to use this, and at some point it became really widespread. I think CK editor is from the early 2000s, and I'm not sure when TinyMCE started, but there were libraries wrapping this, and people were using it in content management systems and such. So at Mozilla, there was a feeling we have to do something like this as well. This is a useful feature, but they didn't quite like what Microsoft had done, and this was the browser war, so it was not like there was a very good communication or standards process. And they spent some time trying to come up with a better solution, but they never really agreed on something. So in the end, they said, OK, we'll just do what Internet Explorer does so that we're no longer left out when it comes to rich text editor in the browser, rich text editing. So they copied this feature. Of course, they didn't exactly copy it. They thought some parts of it were no use, so they left those out. They thought they knew better solutions for some other parts. So for example, where IE would add B text if you made something bold, they thought, no, we have CSS, so it adds spans with font weight on them. I'm not sure why. So you had the feature on both major browsers then. And a few years later, actually, it took until 2007, which is past the JavaScript boom, that Firefox also added support for contentEditable. And then the other browsers, Safari, Chrome, Opera, all also took up this feature and implemented it one way or another. And now it's kind of considered part of the expected API in a modern graphical browser. So why is this a good thing? The other controls that we have to implement editing in the browser are text area and text input, both of which are constrained to atomic blobs of plain text. You can't really do many of the things that you want to do with them, like doing rich text in them is a non-starter, and even adding some helpful widgets or syntax highlighting is almost impossible to do on top of a text area. So it's great that we have an alternative that we can do solid rich text editing, or more or less solid rich text editing in the browser. And things like content management systems that exist entirely online, early code editors were also based on this. This is wonderful. Except, of course, that it has problems. So a major thing is that HTML's scope is gigantic, and what you get with contentEditable is an HTML editor. And you might not want that whole scope. For example, the first version of CodeMirror, my code editor, was based on contentEditable, and people would paste images, links, whole tables into the editor, and I had to somehow deal with this. So you can do that. You can filter the content. You probably want to filter the content anyway, because the HTML that comes out of this by default is very, very ugly. So that modern WYSIWYG browsers have implemented pretty advanced mechanisms for filtering and cleaning up the HTML inside of the editor. But then there's still all the browser differences. There's no spec, and each browser. So this is a very big scope of what editing HTML really means. So there's cursor motion through tables, adding columns to tables. What happens when you press enter in a definition list? What exactly is the cursor position if it's moving across the boundaries of block elements? What is a valid cursor position? These are all difficult questions, and browser vendors came up with slightly different answers to all of them. And then there's bugs, many bugs. So the feeling I get is that no one really, maybe except for the few engineers that started this thing, no one really felt like implementing this. But it was something that is needed and expected, and so all the browser vendors had to somehow add this dragon of a submodule into their browser, which interacted with everything in all kinds of horrible ways. And bugs would languish in bug trackers for years and years because it seemed no one really cared all that much. The situation has recently improved. Currently, on modern browsers, you can really make some assumptions about what's going to happen to your HTML as the user is editing it. It didn't used to be the case. In CodeMirror 1, I had just piles and piles of workarounds to deal with all these weird issues. And it was only a text editor, so I think it's going to be a lot worse if you actually support rich content. So people really got annoyed with this, and then there's a generation of editors. They started with code editors who just say, OK, we're not going to touch this at all. We'll figure something out ourselves. We implement everything. So we implement our own cursor, our own selection. Just the DOM is not actually editable. We just pretend it is by capturing events and changing your document that you're seeing on the screen in response to those events. So this was the first one to pull this off really well was the ACE code editor. At that point, I was still messing around with contentEditable in my own code editor, and I saw what they were doing, and I said, OK, this is clearly superior. So I ported that, and I just dropped contentEditable and never looked back. That works. Google Docs also uses this approach. What you're seeing blinking on the screen is not an actual browser cursor. It's just a little div that's hidden and shown periodically. And you can get really far, especially on desktop browsers. You can get a very good editing experience using this technique. So, but at some point, you do run into problems. Like if you maintain your own selection and cursor entirely, you get all the complexity of bidirectional text on your plate. You have to implement what the cursor is supposed to be doing if it moves to right to left and then enters left to right text, and there's an island of another kind of. So this is when you're mixing Arabic or Hebrew and other scripts, you just get islands inside of your paragraphs that are running in different directions. And people need this. Like Arabic or Hebrew writers really need this to work, and they won't be able to do much with your editor if it doesn't work, but it's gigantically complex to get right. And then there's simple things like the context menu should show cut and paste if you click on it, but if you just have a non-editable div there, how's the browser going to know to show cut and paste or select all in your menu? You can find hacks for that. The hack for this thing is to quickly pop up a tiny transparent text area under the cursor when the user right-clicks, and then kind of hook that up to do the right thing when he cuts or pastes. And it's you can get it to work, but it's painful and awkward. And then mobile interfaces, touch interfaces became widespread, and there the integration between the selection and the touch interface is very deep and very subtle. And producing a native selection, a native field to manipulating the selection when you're not actually letting the browser know about the selection is almost impossible. I don't think anyone has pulled it off yet. So this may not be the right solution either. So maybe let's meet in the middle, and this is the idea that prompted ProseMirror. Let's give the browser its editable DOM so that it knows the user is editing something. But then when the user actually does something and that generates an event, we just step in and say, OK, don't do anything, browser. We'll prevent default this. We'll handle this. And that isolates us from a lot of the horrors of contentEditable, because the random manipulation of the DOM by the browser is no longer happening. And it allows us to really define our own document model and be the only one touching that. In the old approach, the DOM is your document model. So you're you don't keep your own copy of the data. You let the DOM determine what the document looks like, but you don't know what the browser is going to do to this. So it's kind of like building on quicksand. Things might change. Nodes that you somehow depended on existing may suddenly vanish or be replaced by a copy or who knows what. Having full control over your document model is a very, very useful thing to do. And I think some of the other WYSIWYGs that have cropped up recently are also moving in this direction. Yeah, ProseMirror is designed from the ground up with this assumption that we have a document model, and then there's a DOM. And the DOM is just a view on this document model. The document is solid. We control it entirely. And when it's changed, we update the DOM ourselves and show the user their pseudo-editable thing, which is supposed to be editable, but which we don't actually let them edit directly. And that gives us basically the best of both worlds. The selection is now a real selection. You can manipulate it on a touch interface. Bidirectional text, cursor motion through bidirectional text can be left to the browser. We don't want to think about that. That saves some complexity. Of course, implementing our own document model and all possible changes on that is also a lot of complexity, but this is complexity that I think you want as a text editor, because you want to define these in one predictable, well-defined way, and you want to make them customizable. You just want to cut out the browser when it comes to that. So I'm going to go into ProseMirror's document model for a bit. It's list-based, it's tree-based, much like the DOM. So if you have a document with a list of 3 items, it looks something like this. You get a list node with 3 item nodes, with 3 paragraph nodes, with some text content in them. One thing that it does very differently from the DOM is that it's a persistent data structure. So if you update it, you create a new version, and the old version is untouched. So you don't just go in there and start adding children, I don't know where. There's a well-defined set of possible updates, and you apply an update to get a new document. And this is not as expensive as it sounds, because it can do data sharing. If you add an item to this list here, you just reuse the old item nodes and make a copy of the document in the list node with a fourth child in the list node. So you're only copying 2 nodes rather than your whole document structure. Another thing that ProseMirror does differently from the DOM is that when you have inline content, this is how you would represent a paragraph with a piece of bold and linked text in it. In the DOM, well, the node names are different. But so you create a subtree with, for example, a strong node, and then you put the content that's strong under that. ProseMirror actually makes this linear, where inline paragraph level content is always just a sequence of pieces of text with styling information, or images are also nodes that can appear here, but they don't nest. Beyond the paragraph level, there's no nesting, and you can kind of see how this is harder to read than this. And it's the same when you're dealing with it in code. A lot of the things that you want to do are much easier on this. So for example, verifying that you're not emphasizing a piece of text twice is trivial in this representation, is a pain in a tree representation. Similarly, if we want to represent positions in a paragraph here, we can just use a character offset, and we don't have to worry about tree relations. So this was a big win, and made it easier to define a lot of things. So let's see what happens when ProseMirror captures events. You have your editor. It's rendered a piece of editable DOM corresponding to the document that it has itself in memory somewhere, and someone presses A. So we capture the event for that and create a change object. Changes in ProseMirror are first-class objects, which you can store and pass around. We'll come back to that later. And then we apply that change object to our current document, get a new document, make that the current document, and schedule a DOM update. Similar for if you press backspace, you just compute what you want to be deleting with backspace, create a change for that, if the user pastes, we take the content of the clipboard, paste it, parse it into our document format, and replace the selection with this parsed document fragment to get another change object. Updating the DOM is then done by, as I said, scheduling an update using request animation frames, so that the next time the browser does an actual redraw, it'll first run our code, which is responsible for making sure the DOM reflects the current document. And a nice thing about these persistent document structures is that we can do pretty much what React does. We can diff the document at the last DOM update with the current document, and only make the changes to the DOM that are necessary to move from the old object to the new document. And this is insanely efficient and fast. Because these data structures are persistent, we can usually just do one pointer compare to see, okay, nothing changed here, and move on to the next node. Of course, it's not entirely perfect. In some cases, browsers do not fire a useful event. A good example is the built-in spell checker. When you get this wiggly underline and you right-click and you say, OK, I'll choose another spelling of this word, then it'll just modify the DOM and then say input, meaning something changed. You don't know anything about it. So we have to deal with that. And in this case, we just take the part of the DOM, like the block elements around the cursor, reparse those, diff them with our understanding of what those parts of the document look like, and derive a change from that. Fortunately, so far, I've only run into this problem for simple textual changes. And deriving a simple textual change is safe. There's nothing weird that can happen there. So far, this is working well. I'm still expecting at some point to run into more problems here. So having all these persistent objects representing everything in a nice value way, we can define a kind of algebra of changes. So the basic operation is applying a change to a document. So here we have a blue thingy for a document and an orange thingy for a change, and we apply that, getting a new document. So in this case, we delete the part in the zeroed paragraph between character offset 2 and 8. Deleting one word, we get a new object, a new document object, and also a map. A map is a position map. Is a way to associate positions in the pre-change version of the document with positions in the post-change version of the document. So in this case, we can query this map to ask cursor position in the first paragraph at position 11 in the old document. Where is this in the new document? And it'll say it's position 05, meaning the 5th character in the first. So this is mainly used for making the cursor move as the document changes. So the cursor shouldn't just jump around, it should stay in its position. But there's a bunch of other nice things you can do with this, like tracking pieces of the document. You just create 2 positions somewhere in the document around the part that you're interested in, and as the document changes, you keep mapping those to the new document, and you end up knowing exactly where the text that you're tracking ended up. And this is also essential for collaborative editing, because it allows us, by mapping the positions associated with a change object, to move changes from one document to another version of that document. So, for example, if we had, beyond this delete operation, we had another change object saying insert a character at position 11, we can now say that same change, but applied to the second document, is insert the same character at position 5. So if you have a collaborative editing setup and two users make edits concurrently, one of them will end up going first, and the other one will have this change that they've made, but that they're not able to apply to the current document because the document changed in the meantime. They can use this approach to take the change that the other user made, move their own change over it, and then apply it and retry pushing it to the server. So it's kind of like git rebase. You try to push, you get a conflict, so you first rebase locally, and then you try to push again. And this works very well. There's quite a bit more to it, actually. You can find a long description about it on my blog. But it works well, and it's a very solid and relatively simple way to do collaborative editing. And there's more applications of this, say change tracking. If you just keep a history of all your changes, you can always find out where a piece of the document originated, stuff like that. And I'm sure there's more. We haven't really explored this far yet, but it's a nice basis to build on. Then I want to very briefly talk about the future. So the W3C is working on an update to this content-editable standard, which would allow a new mode of content-editable where you're supposed to do exactly this, basically. The document isn't actually editable. You're expected to capture events and implement the editor yourself. And then they will also have to define a few more events for stuff like the spell checking issue that I showed before, and there's a bunch more like this. Yeah, that would be nice because it relieves the browser vendors of maintaining this whole horrible blob of code. And it gives editor implementers a clear view of how to implement an actually robust, solid editor without going insane in the process. Of course, you never know when a W3C standard is going to actually end up in browsers, but I'm told that browsers are enthusiastic about this, probably for the reasons I mentioned, and that it might actually be happening. But the spec isn't finished yet. It will probably be a long time. That's it. These are the relevant URLs, the project page and the GitHub repository. It's MIT licensed, so feel free to play with it. It's not really finished yet, I would say beta status, but it works as it is. The major big thing that has to be improved is an API or a language for defining your own document schemas and having more flexibility there for all kinds of features that you might want in your document schema. We're having a meetup on Monday around this project here in Berlin. So if you think you might be interested, go to discuss.codemirror.net. It's a discussion forum, and one of the top topics is about this meetup. You're welcome to drop by as well. That's it. Thank you for listening.